Okay, so here I'm going to be going through the solutions for the Emcf. So let's get started. So number one, it says the distance between the point, I'll just call it P, is 3, 1, 4, and Q is equal to 4 minus 1, 2. Okay, so I want the distance between these 2 points, so that's just going to be, I'll call it distance from P to Q. That's going to be square root of, here I don't care which direction I'm going in, so I'm going to go 4 minus 3 squared plus minus 1 squared plus 2 minus 4 squared. That becomes 1 squared plus minus 2 squared minus 2 squared. It's 1 plus 4 plus 4. 4 plus 4 is 8, plus 1 is 9. So that's going to be square root of 9, which gives me an answer of 3. Next question. It says the midpoint of the line segment connecting P is 3, 7, minus 4. And 2, I'll say Q equals 2 minus 1, 6. Okay, so we want the midpoint of the line segment connecting these two. Real quick, let me just mention that I can write the line segment. So I'll say like y of t. This is very easy. I just do t times p plus 1 minus t times q. I don't need that in my solution at all. I'm just mentioning that's what the equation of the line would be. And we could just take t equals to 1/2, and that would give us the halfway point. But there's an easier way. The easier way, I'll call the point M for midpoint. It's just going to be the average of these two. So I'm going to do 3 plus 2 over 2. And then I have 7 minus 1 over 2. And then minus 4 plus 6 over 2. Which actually is exactly what I would have gotten if I would have done 1/2 times 3, 7 minus 4. And I plug in 1/2, so I get 1/2. 2 minus 1, 6. Okay, so I simplify this, and I get 5 over 2, 6 over 2, which is 3, and then 6 minus 4 is 2, so 2 over 2. 5 over 2, 3, 1. Is that an option? That is indeed an option. That's my answer. Number 3. An equation for the sphere centered at, so C is minus 1, minus 2, 3. So that's the center. And passing through the point 0, 0, 0. So we know that the point, I'll call it O, is on the surface of the sphere. Okay, so to get the radius, all we need to do is find the distance from the center to this point on the surface, because that has to be the radius. And then we can just write down the equation right away. So the distance from C 2o to the origin, it's going to be minus 1 minus 0 squared minus 2 minus 0 squared plus 3 minus 0 squared. So we have square root of 1 plus 4 plus 9. It's going to be square root of 14. So the equation of the sphere, we're going to have x. So here we need to subtract off a number that is 0 at negative 1, at x equals negative 1. So we're going to do plus 1, because at negative 1, this term vanishes. So same thing for the next one, plus y plus 2 squared. Right, so the negative of this. Actually, you know what, a better way to write this would be like this. Minus 1 squared plus y minus 2 squared plus y minus z minus 3 squared equals the radius squared. Square root of 14 squared, which simplifies x plus 1 squared y plus 2 squared z minus 3 squared equals 14, which was answer choice B. All right. So here we have a very similar question to the homework. So it says x squared plus y squared plus z squared minus 8x plus 4y plus 6z plus 25 equals 0. So it says if this is the equation of a sphere, then what is the center? So to do this, we just start completing the square. So I have x squared minus 8x. So I need to add something. I'll come back to that. Plus y squared plus 4y, leave a gap, plus 7 squared plus 6 z squared plus 6z, leave a gap, equals minus 25. 1/2 of negative 8 is negative 4 squared, so I add 16. 1/2 of 4 is 2 squared, I add 4. And here I add 9. So that's 29. So this is going to be 4. So we'll see that the radius is 2, but that wasn't. Is that the next question? That might be the next question. Yeah, okay. So here we factor this. This is going to be 8 minus x minus 4 squared plus y plus 2 squared plus z plus 3 squared. And again, this number is half of that number. And we chose this number specifically so that we can factor it in this sort of way. Anyways, so we see that the center is when this, and this are 0. So that means the x component is 4, y is equal to minus 2, z is equal to minus 3. So the center is 4 minus 2 minus 3. And this is equal to 2 squared. So number 5 we have right away. The radius is equal to 2. Okay, moving on to number 6. So it says A is the point 2, 9, minus 1, and B is the point 6, 5, 1. Okay, and it says these are the endpoints of a diameter of a sphere. Find the equation of the sphere. So if these are endpoints on a sphere, right, they're basically just on opposite ends. So if I connect those two with a line, the middle of those lines is going to go through the center of the circle. So we can find the center by finding the midpoint of A and B. And then we can do what we did in the last one and find the distance. We could either do the distance from here to here and divide by 2, or the distance from here to the center, and that'll be the radius. So let's find the center. So the center is going to be the midpoint of these 2 points. So I'll 2 plus 6 over 2, 9 plus 5 over 2, minus 1 plus 1 over 2. So this simplifies to, let's see, that's 8 over 2, that's 4. 14 over 2, that's 7, and that's 0. So that's the center of our sphere. Now, to find the radius, I can either find the distance from C to either B or A, or I can find the distance from A to B and divide by 2. I'm going to find the distance from C to B. So this is going to be square root 6 minus 4 squared, 7 minus 5 squared, 1 minus 0 squared. So that's going to be 2 squared plus 2 squared plus 1 squared. 4 plus 4 is, or 8 plus 1, that's 9. Square root of 9 is 3. So why did I choose distance from C to B? I just chose it because it looks like the numbers would be easier to subtract in my head. There's literally no other reason than that. But now I can write the equation of the sphere. So this is going to be x minus 4 squared plus y minus 7 squared plus z minus 0 squared equals 3 squared. Well, I guess this would be 9, but same thing. Okay, number 7. Given points P, which is 6 minus 1, 7, Q, which is minus 2, 1, 3. It says find the magnitude of the vector from P to Q. So if I just draw these in 2D real quick for example, right, if I have 2 points, here's P and here's Q, and I want the magnitude of this vector. Okay, this is just the same as, or I want the magnitude of this vector. This is the same as just asking what is the distance between these 2 points. And it turns out to be exactly the same. So I can either find this vector explicitly and then take the norm, or I can just find the distance between these 2 points. It comes out to being the exact same computation. I'm going to go ahead and find the vector. So the vector PQ is going to be Q minus P. And I'm going to put these as a little arrow and just treat these as vectors, even though they're technically points. Because I can't add points, I can add vectors. So 6 minus 2, that's going to be 8. Minus 1, that's minus 2. 7 minus 3, I'm doing this backwards. I need to do Q. Okay, so minus 2 minus 6, that's minus 8. 1 minus 1, that's 2. 3 minus 7, that's minus 4. Okay, so this is this vector, and we want to take the norm of this. So norm PQ is minus 8 squared plus 2 squared plus minus 4 squared, square root of 64 plus 4 plus 16, square root 84, which comes out to be, is that right? Yeah, okay. So I guess I could technically simplify that because I can factor out a 4. So that'd be 2 root 21, but this was the answer choice. Okay, number 8. It says if A, which is 2, 1, minus 1, B, which is minus 6 alpha 3, are parallel, then alpha is what? Okay, so if it's parallel, then we know that alpha equals something times beta. Right, so here this tells me that 2 equals something times minus 6, and then 1 equals that same lambda. You know what, I guess it'd actually be slightly easier to write it as the other way around. Just to avoid fractions, but it'd come out exactly the same. Okay, so here I have 2 lambda equals minus 6, and then I have lambda equals alpha, and then I have minus lambda equals 3. So that right there tells me lambda equals minus 3, and this right here tells me that alpha equals minus 3. Okay, here, no, this is right. This is right. Okay. Next question is what I was looking at. That was number 8. Number 9. It says A, which is 3 minus 3, 2, and B, 1 alpha minus root 5, have the same magnitude. So what it's saying is that norm of A is equal to norm of B. So that's what it's telling us, and it says what is alpha. So real quick, just to make things easy, so I don't have to deal with square roots, or so I don't have to keep writing it, I'm going to square both sides. And this allows me to ignore the square roots for now. Okay, so here I have that the norm of A squared, that's going to be 3 squared plus minus 3 squared plus 2 squared, should be equal to the norm of B squared. So that's going to be 1 squared plus alpha squared plus minus root 5 squared. Simplifying, this is 9 plus 9 plus 4 equals 1 plus squared plus 5. 99 is 18, that's 22. 6 plus alpha squared. Subtract 6 from both sides, and I have 16. Yeah, 16 equals alpha squared, which means that alpha equals plus or minus root 16. Alpha equals plus or minus 4. And that's my answer. Next question. Okay, so for the next 3 questions, it tells me that A and B are vectors and that the norm of A is 2, the norm of B is 3, and that the dot product of the two, A dot B, is 4. So it says, so number 10 is evaluate norm of 3 times a minus b. So this might seem weird that we have to evaluate this norm and we don't actually know what these vectors are. But I can use so I'm going to square this for now. Let me put that in red so I remember to come back to it. So I'm going to square this for now. So the norm we know is the square root of x dot x, right? We know that norm x is square root x dot x. So this is just going to be, so I square both sides, I get rid of the square root. So I have 3 alpha, not alpha, 3a minus b dot 3a minus b. And then now I just use the fact that this is distributive, right? So I just distribute. So I have 9a dot a. Then I have 3a dot minus b. So I can combine the negatives. So I have minus 3a dot b. Then I have the same thing again, except this is b dot a. And then minus b dot minus b. That's going to be plus b dot b. Right, I pulled both of the negatives out. Negative times negative is a positive. So this becomes 9 times the norm of a squared. Here I use the fact that I can swap the order of a and b, right? I can interchange them. It's symmetric. So this becomes minus 6a dot b plus norm b squared. Plugging in numbers, I have 9 times 2 squared minus 6 times 4 plus 3 squared. 9 times 4 is 36 minus 24 plus 9. So this is going to be 12 plus 9, that's 21. Okay, but that's not my final answer because I still have to take the square root. So that tells me that 3a minus b is equal to the square root of 21. And it's not plus or minus because distance is always positive, or magnitude is always positive. Okay, same sort of thing, except for a plus 2b dot 3a minus b. So this is number 11. Okay, so I do exactly the same thing. I start distributing, so I have 3a dot a minus a dot b plus 6b dot a, and then minus 2b dot b. Rewrite in exactly the same way, 3 norm a squared. So again, I swap the order. So I have minus ab plus 6ab, so that's going to be plus 5a dot b minus 2 norm b squared. Plug in numbers, 3 times 2 squared plus 5 times 4 minus 2 times 3 squared. That's 12 plus 20 minus 18. So that's 2, that's going to be 14. And I don't have to take the square root because I didn't square this for any reason over here. It was just already like that. Where's my cursor? Okay. Okay, so given those same vectors, it says find the cosine of the angle between A and B. Right, so if we have A, we have B, and we want the cosine of this angle. Okay, so if you knew specifically what A and B were, I guess you could figure out what this angle is. It would be a pain because they're not guaranteed to line up on the same plane. Well, on one of the nice axes, right? It's not just XY plane, right? So they might be in the same plane, but it might be like some weird offset plane, and then you have to figure out the angle from there. So I guess you could figure it out, but with if you knew the vectors exactly, but we're not going to use that. We're going to use the formula that the cosine of the angle between the two is equal to A dot B over norm A norm B. Okay, so we can just start plugging in, right? This is going to be 4 over 2 times 3, which is just 2 over 3. And I'm done. Right, so the angle between these two vectors is whatever the arc cosine of 2/3 is. Number 13. Find the vector with norm 2. So I'm finding the vector, I'll call it v, with norm 2, equals 2, and with opposite direction to, with the direction opposite to the direction of a, which is I hat plus 2j hat minus 2k hat. Okay, so let's find, let me draw a quick sketch. So here we have some vector a, and we want to find the vector with a length of 2 in the opposite direction. So the easiest way to do this is to find a unit vector that points in the same direction as a, and then multiply that by minus 2, and that's going to go in this direction. So let's find a unit vector in the same direction as a. So to do that, we just need to find the norm of a, which is square root 1 squared plus 2 squared plus minus 2 squared, and we've seen this several times. This means that norm of a is 3. So a unit vector in this direction is going to be a times 1 over 3, or 1 over the norm. So that's 1/3 I hat plus 2j hat minus 2/3 k hat. Okay, so this is the unit vector. I'm going to call it a hat, right? The hat means unit vector, and it's pointing in the same direction as a, right? So it's this little thing right here. Now, if we multiply this by minus 2, it's going to be still pointing along the same line, just in the opposite direction, and it's going to have a length of 2. So v, the vector we're looking for, is just minus 2 times a hat, right? Remember, this is the hat, the unit vector. So that's going to be minus 2/3 I hat minus 4/3 j hat plus 4/3 k hat. So it looks like the answer choices were actually given in a factored form. So that's going to be, let's see, which one do I want to do? If I factor out the minus 2/3 times I hat plus 2j hat minus 2k hat. Right, because all I did was I divided by 1/3, and then I multiplied by -2. And that's my answer. Okay, a quick one. It says the angle, so number 14, between A, which is -1, 1, 2, and B, which is 4, 2, -2. So again, we use the same formula. Cosine theta is equal to A dot B over norm A, norm B. Okay, so let me do these computations off to the side over here. Um, so A dot B, that's going to be -4 plus 2 minus 4. That's -8, that's -6. Okay, the norm of A, that's going to be square root 1 plus 1 plus 4, it's root 6. And then norm B is 16 plus 4 plus 4, which is root 24. Okay, yeah, I see how this works. So we plug this in and we have -6 over root 6 and root 24, which is the same as 2 root 6. So root 6, those come out to be 6, and they cancel on top, so I just end up with not -1/2. So the angle between these two vectors is the angle whose cosine is -1/2. And the angle whose cosine is, let's see, so the cosine is -1/2. That's going to be 2 pi over 3. Because, yeah, 2 pi over 3. Okay, two more. Number 15. So A is 3 minus 1, 2. B is 4 minus 3, 0. It says the projection of A on B, so projection of A onto B is equal to lambda B, and we want to find lambda. Okay, so we just use the formula for the projection, for the vector projection. Okay, so the formula for the projection of A in the direction of B onto B is A dot B over norm B squared times B. So here we see that this right here is the lambda that we want. So we just need to compute the dot product and the norm of B squared. So A dot B is equal to, that's going to be 12 plus 3 plus 0, that's 15. And then norm of B squared, that's just going to be 16 plus 9 plus 0, which is 25. So lambda is going to be 15 over 25, which is 3 over 5. Okay, another way to look at this, again, just as a reminder, this is A dot B hat. So B hat is a unit vector in the direction of B times B hat. Okay, so the component of A in the direction of B, that's just going to be this bit right here, right in the parentheses. So number 16, the component of A in the direction of B. So here, one of these norms was used in making this a unit vector, right, to write this. The other one was used in making this to write a unit vector. So here, this is just to help you remember that when I do the component, it's not going to be the norm of b squared, it's just going to be b. Right, so basically I just count the number of b's that I have showing up in my formula on top, and that's what I need to divide by the norm of. A dot b divided by norm of b, right? Not squared, just norm of b. So we already know what these are. This is 15 on top, and on the bottom, that's the square root of 25. That gives me 3. All right, so those are the EMCF questions.